Hey guys, welcome to Ergo Forces. So today we'll be moving ahead with Leetcode problem 100532, that is minimum cost to make the arrays identical. So first I'll go through the description, then I'll explain you the approach, and then we'll be moving ahead with the coding part. So it is saying that you are given two an integer arrays, that is ARR and BRR, of length n and an integer k. Now you have to perform, you can perform two type of operations. So first is that you can split the array into any number of contiguous sub arrays and rearrange them in any order, and the operation has a fixed cost k. Okay, so let's say you are given array like this, minus 7, 9 and 5. So I have to split in some contiguous arrays, like for example 7 and then 9 5, or maybe I can also do it like 7 minus 7 9 and 5, and I have to rearrange, so the final array will be 5 minus 7 and 9. Similarly, you can think of any further permutations. Now, the second operation is we can choose any element in array and add or subtract a positive integer x to it, and the cost of this operation is x. Okay, and what we have to do basically is we have to return the minimum total cost to make array ARR equals to BRR. Okay. Okay, so let me just explain you now what it means. Okay, let's say that you are given two arrays, A equals to minus 7, 9 and 5, and B equals to 7, minus 2 and 5. Now you have to make minus 7 equals to 7. So how can you do it? You can either add or subtract any positive integer from this 7, and you have to also keep track of cost. Let's say I'm taking cost as C. Okay, initially it was 0. Initially it was 0. So now basically, if I want to make minus 7 equals to 7, so what I'll do, I'll just add, I'll just add 14, right? Sorry, I'll just add minus 14. Okay, so let's say here, so basically if I'm not doing operation 1, I'm just doing operation 2, right? That is, adding a positive integer I'm adding a positive integer here. So basically, let's say what is the cost of making 7 equals to minus 7. So here it will be 14. Okay. Now similarly, if I perform operation 2 on this one, that is minus 2 and 9. So what it will be? So it will be 11. So 14 plus 11. Okay. And similarly, if I perform operation 2 on 5 and 5, so it will be 0, right? So what is the total cost? It is 25, right? Okay, now let's say I'm performing operation 1. I am, let's say, rearranging array A so that I have to minimize the cost. So what will be the most optimal rearrangement? So let's say for 7, I will have either 5 or 9, because the difference of 7 minus 5 and 9 minus 7 is same, right? Or for minus 2, it should be minus 7, because it is the minimum possible cost of adding or subtracting a positive integer. Now for 5, it should be 5 only, right? So because here only the difference will be 0, so here instead of 5 I will take 9. Okay, so the most optimal arrangement will be 9 minus 7 and 5. And what is the cost in this case? So in this case, cost is 2, 2 plus 5, so it is 7. Okay. So if you have noticed carefully, then what we are doing here, so basically we are trying to find the from closest element from each of the elements in the array B. So basically I'm finding the closest element from 7, that is 9. Then I'm finding the closest element from minus 2, that is minus 7, and then from 5 it is 5, right? Okay, so do observe here carefully. So can I take 5 for minus 2? No, right? Because in that case the cost will be maximized. I mean, it would not be the minimum cost, right? Because if I'll take 5 for minus 2. So in that case, for 5 I would have to take 9 or minus 7, right? So that is not possible. So basically for minus 2 I have to take minus 7 only, right? So and for 5 I have to take 5 only, and for 7 I have to take 9 only. So do you realize one pattern here? So that is for minus 2, minus 2 is the least is the lowest element in this whole entire array B, and here minus 7 is also the least element in the entire array A. Okay, so if you observe carefully here, what we have to do is we have to rearrange the elements in array A and in array B such that the at each proposition the elements in both array A and array B at that particular position should be closest to each other, right? So if minus 7 is the lowest element in A, so in that case we have to find the element in B which is also the lowest. So if the element is minus 7, so for that we have to find minus 2 only, right? Because this is the lowest element in array B and this is the closest one to minus 7. If I would have taken 5, then that would not give me proper minimum cost. Similarly, for 5, my element would be for 5 my element would be 5 only, right? And as we can see, this is the second element in the sorted order, right? And similarly, if I take 9, so for 9 it should be 7. Till now you must have got it that we have to sort both arrays A and B, okay, so that we can find the closest element at a particular position. So okay, so let's see what happens if we sort these arrays. So A gives minus 7, 5 and 9, okay, and B gives minus 2, sorry, minus 2, then 5 and then 7. Okay, so what will be the cost here? So first of all, if you notice, we have rearranged the arrays, right? We have rearranged the array A. It doesn't matter if we rearrange the array B or not, but if you will rearrange the array A, then the cost will be equal to K. So if the K is 2 here, then I have to initialize C by 2 because we have rearranged the array A. Okay, now, so what will the cost of making minus 2 equals to minus 7? So that would be 5, right? So it is 2 plus 5. You have to take absolute difference. Now, for 5 and 5, it is 0. And for 9 and, sorry, and for 9 and 7, it will be 2. It would be 2. Okay. So as you can see here, initially we have calculated the cost of performing operation 2 is 7, and and here we have also rearranged the array, right? So the total cost would be here, this 2 is the total cost of rearranging the array, and then comes this 7. So the total cost is 2 plus 7, that is 9, right? And that is quite less than the 25 which we saw before. So 9 is our correct answer. So basically what we are doing here is we are just sorting the arrays so that we can just find the closest element. From minus 2 is minus 7, then from 5 is 5, and then from 7 is 9. So basically we are just making A and B at their proper positions. Okay. So okay. And here we are sorting B as well because we have to make both the arrays at their proper positions. So now what is the time complexity of this solution? So it should be order of n log n because we are performing sorting, and for the space complexity it should be order of n, right? Because we will have to take two arrays as well, that is two temporary arrays to store the original arrays, because we also need to make sure that we consider that what if we do not rearrange these arrays and just we perform the operation 2, then will that cost be less than this cost? In that case, the previous cost will be the answer. So we also have to make the original arrays intact in some temporary array. Okay, I hope you got the solution. Now let's move to the coding part. Okay, so what all do we need here? So as I have mentioned before, we will need two temporary arrays. Temp1 equals to, I just take a clone of array, and then similarly one temp2 for storing the BR. Okay, now what I'll do is I'll just sort both of the arrays, ARR, and similarly I'll sort BRR as well. Okay, now what I'll do is first I'll have one cost variable, and then cost1, and then cost2. Okay, now what I'll do is this cost1 would be the cost if I do not perform any operation 1, that is I do not rearrange the array. So in this case, what will be the answer of cost to 1? So it would be, I'll just have to loop to the array and I plus plus. So I'll just take absolute of cost1, absolute of ARR I minus BRR of I. Okay, so this is my cost 1. Now what will be the cost 2? So for cost 2 we are taking use of, sorry, this is temp 1 because we are not sorting the array in this. We are checking it without sorting. That is, we are just performing operation 2. 2 only. I have mentioned it in the comment section. Now operation 1 and 2. So for this I have to make use of the sorted arrays. So I again loop through the array. So cost2 plus equals to math dot absolute of array of I minus, okay. Okay, now I just have to return minimum of both of them, cost 1 and cost 2. But also there is one more thing. So in cost 2 we have sorted, right? But we have to check whether if we sort whether the elements are at their initial position only or not. So if they are at the initial position only, let's say the consider the case of this. So you have been maybe let's try, instead of 2 1, if you are given 1 2, okay, and you are sorting 1 2, so it will again give me 1 2, right? So in that case we do not have to add k because they are already at their proper position, and we do not need to, we are not rearranging the arrays in that case, so we do not need to add k. So how would we get that? So basically I'll just loop through the array once again and I plus plus. Now we have two arrays, original array and the sorted array. So I will check if array of I not equal to temp1 of I, and or it also might happen that, let's consider a case like this where a equals to 1 2 and b equals to 2 1. Okay, so even though here a is sorted but b is not sorted, right? So in this case what, as per the question, it is saying that if we have to rearrange the array, then we have to add k, and here we have to rearrange. Let's say if I'm not sorting b, then I have to rearrange a as 2 and 1 so as to make it at its proper position, right? So we have to add k here anyways. So in this case, like we are already sorting a and b, so what we'll do is I'll also check if b is already say at its position, that is if the position of b is same as the original position. If not, then I'll add k. Okay, coming back to coding part, so I'll also have to check for b array. If b array of I is not equal to temp2 of I, then I have to initialize cos 2 by k and I'll break. I do not have to check for each and every element of the array, because if one element is not same, if the position of one element is not same as the original position, then it is sure that we have rearranged that array, right? Okay, so let me try to run this solution. It is giving some compile. Okay, yes, so we have made a mistake here. Basically this should be long, and they are also expecting the result as long, because it might happen that here the elements of the array can go till 10 raised to 5, and we are it might happen that this cost one might exceed the integer limit, so we have to make it long. Now let's try to run it. Okay, so let's try to check the answer. So it is 13 0 2 and 8. So I'll just try to submit it. Okay, it is accepted. So this is the whole solution. If you have any doubts, just do comment in the comment section. And I hope you like and subscribe this video. Okay, then bye bye.